So let's solve this assignment on dimensions. We'll find the dimensions and units of force, density, and pressure. For force, number one, force. We know that force is defined as the product of mass and acceleration. That means that F, force, is equal to mass times acceleration okay. It means that F is equal to ma for short. Now we go further. Force is equal to m is mass. The symbol for mass as a fundamental physical quantity is capital M. So we put it capital M, then times by acceleration. Acceleration is defined as velocity over time. Let's bracket it. Acceleration, velocity over time. Velocity over time. And what is velocity? In the previous class, I gave you that velocity is equal to displacement over time. And I said that displacement is distance traveled in a given direction. You know the direction, maybe 20 kilometer south, 20 kilometer north, or 5 kilometer east. You know the direction and you know the distance traveled. That is displacement. If you don't know the direction of the movement, we just use distance to refer to it. Velocity now is equal to displacement over time. Now this means that velocity is equal to displacement is also talking about distance, and when we are talking about distance, we are also talking about length. So we use length to represent displacement, and length is a fundamental physical quantity. So we look for the symbol of length as a fundamental physical quantity. Length is represented with capital L, then over time. Time is also a fundamental physical quantity and is represented with capital T. So we put it there. So velocity is L over T. So we use this to put in place of velocity. And so we have This place that we have velocity over time, we use this to put in place of velocity, and then we divide it again by this time. So what we have finally is that acceleration A is equal to L over t. This one represents velocity, then everything divided again by time, which is the second this t here. And so we have that this is equal to acceleration is equal to L over t divided by t. Anything standing on its own is over 1. So we have acceleration is equal to L over t. Now this is division sign. If you want to change this division sign to multiplication sign, we invert. Okay, let me put it. This is over 1. So if we want to change it from multiplication here from division here to multiplication, we invert this. So what we are going to have is 1 over t. 1 over t. And so we have that acceleration is equal to, this is multiplication now. If we put multiplication and remove division here, we invert the second species. So we have 1 over t. So we times L times 1 and t times 2 times t. So we have L times 1 is L over t times t is t squared. So acceleration is equal to L over t squared. So we carry this L over t squared and replace acceleration in the formula for force. Mass times acceleration. So we use m to represent mass, and then the dimension for acceleration which we've gotten, we use it to replace a. So the final thing, we have that force, the force which is ma, is now equal to m is mass capital, then times by acceleration, we got it as L over t squared. So L over t squared. This m is m over 1. Anything standing on its own is over 1. So we can still put this in over 1 so that we can times the numerators and times the denominators together. So we have that f is equal to m times L is ml, and t squared times by 1 is t squared. So what we have is that f is equal to ml over t squared. ml over t squared. This is the dimension of force. This is the dimension of force. And so we now look for the units of force. For us to get the derived units for force, we just come here and look for the unit of m, which represents mass, the unit of L, which represents length, and the unit of time, which represents t, which represents time. Then if there is any superscript, we put it there. Like this one that has 2 as a superscript, we put it there when we write the units. So what we are going to have now is, for m, we have mass is measured in kilogram, and then for L, length is measured in meter, And then for t squared, time is measured in second. So everything over second, we put the superscript squared. So this is the derived unit of force. The derived unit of force. Number 2, density. Density is defined as the ratio of mass and volume. That is, mass divided by volume is density. Density equals mass over volume. Mass is a fundamental physical quantity, so we are not doing any calculation on it. We just leave it and then we face volume. So we have that density now, D, is equal to mass over volume is length times width times height, which is equal to density is equal to mass over length, width and height are talking about the same thing, length. It's just showing the length of the same object on different sides of it. Different sides of the same objects, the lengths of them. So we can use L to represent width and also height. So what we are going to have is that density is equal to m over length times length times length. This is the physical quantity that represents length, width, height. So we have that density is equal to m over length times length times length is equal to L cubed. That's L raised to power 3. L raised to power 3. This is the dimension of density. Let me write it clearly here, that D is equal to M, capital M, which is the dimension for mass, over L raised to power 3. This is the dimension for density. Now for the unit of density, we find the unit of M, which is mass, and the unit of L, which is length, and put the necessary superscripts. So what we are going to have is that the unit is mass is measured in kilogram over length is measured in meters over meters. Then we put the power. So we have meter raised to power 3. This is the unit of density. This is the unit of density. Number 3, pressure. Pressure is defined as force over area. Force that is acting per unit area is pressure. So we have pressure equal to force over area, and so we have that pressure, which we can represent with P, is equal to force we can represent with F. Over area, we can represent with A. We have gotten our force. The first one we solved as mlt squared. mlt squared. mlt squared, that is the dimension for force. So we just carry this and replace F, and then we look for the dimension of the second one, which is area. So what we are going to have is that pressure P is equal to, dimension of force is ml over T squared. We bracket it, then over area. This is representing force. The whole of this is representing force. Then over area. Area is length times width. Length times width. So we have P is equal to ml over T squared over length times width. Length and width are the same. They are talking about the length of the same object on different sides of it. So we can still place W, which is the width, with L. And so we have L times L. And so we have that P is equal to ml over T squared, which represents force, then over L squared. That is L times L is L squared. L squared. Okay, so we can do a little manipulation here. Simplification. We can simplify this to have ml over T squared. This represents the force. Then this division here, we can put the normal division and have divided by L squared divided by L squared. Anything standing on its own is the same as that thing or that number divided by 1. So we can say that this is ml over T squared divided by L squared over 1. And so we have that P is equal to ml over T squared. If we want to change the division sign to multiplication, then we invert this species, and so we have multiplication, then 1. Inverting it means that the one that is under is now going up, and the one that is up is now coming down. So 1 is going up and L squared is coming down. And so we have 1 over L squared. 1 over L squared. There's 1 L up and there's 2 L's down. So 1 can cancel 1 here. This one is gone, remaining 1 here. So we have that P is equal to M. There's no more L on top because this one from here has taken care of it. So it becomes M times 1, which is M. And then the down one becomes T squared times by the 1 L that is remaining here. T squared times L. So what we have is M over T squared L. This is the dimension for pressure. This is the dimension for pressure. We can also write this as, we can make everything to be on straight line, as the dimension of pressure is equal to M. This is a denominator. If you want to bring a denominator up, the superscript, we put minus on the superscript. So we have t, if it's coming up, becomes minus 2. The superscript, which is 2, we put minus there so that everything will be on straight line. So this L, anything on its or standing on its own, is raised to power 1. So this L is L raised to power 1. So we have L, because it is under, if it's coming up, we put minus, then that's superscript minus 1. We can rearrange it to say M, then L raised to power 1, then T raised to power 2. It's the same thing, just that we are bringing this first and then the T second, so that you can have can count 1 before we count 2. And so this is the dimension. If you leave it like this, you got it. But if you want to put it in a straight line, you do a little manipulation to get it to this. Is still correct. So now the unit of pressure P is equal to, we can come here and say put the unit of mass, the unit of length, and the unit of time, and put the appropriate superscripts. So we have mass is measured in kilogram, and then length is measured in meter. The superscript is -1, so we put it -1, and then time is measured in second, and the superscript here is -2, so we put second and then -2. This is the unit of pressure. This is the unit of pressure. If you don't want it this way, we can come to this side and put the units, so that we have we can have that the unit of the pressure from this side is mass. Okay, we put it, mass is kilogram, then over, time is second, it has superscript of 2, we put it over second raised to power 2, and then the last one is length, and the superscript is 1. So if we are writing it like this without trying to put it in a straight line, we may ignore the superscript if it is 1. So we put only second there, meter. Okay, so this is also correct for the unit of pressure. This is how to solve the dimensions and the derived units of force, density, and pressure.